Good evening, guys. Hope you guys are all doing great. Welcome back to another uh, episode of our IPM lecture series, specific to the quant section. So all you guys must have, if you haven't already registered, I'd first of all ask each one of you to register to our channel, subscribe to our channel. Please do watch all our previous videos. I think I've tried to do a fair bit of justice to the kind of questions, the kind of topics. I'm Indore and I'm Rohtak exam, as well as DU-JAT, right? So this lecture series would be relevant even for those guys who are preparing for the DU entrance. That's called the DU-JAT for BMS and BBE and BFIA. Another quick sort of mention, I'm going to share a lot of content with you guys. The link in the description will allow you to register on our portal, on our online testing portal. And while you can access the class exercises from there, you can also upgrade into one of our test series products, whether it's the entire DU test series package or whether it's specific exam specific package that we have for IPM, right? Or maybe some of you are preparing for CLAT. So do if you already haven't, do subscribe, do register at the portal, and make sure that you have access to all of the tests that we have. Let me again underscore the fact that all of our toppers from the previous years have gone through the exact same test series. We obviously keep updating it, but this is the broad pattern in which all of our past students have practiced, and it's clearly given us the results that we have. Last year, two of our students got through IIM Indore, and two others got into IIM Rohtak. In fact, three of them got into IIM Rohtak. So make sure that you do utilize the test series that we have. Okay, I think we're waiting for some people to join us. The meanwhile, yeah, a quick bit of update. I think IIM Rohtak has the IIM Rohtak test, aptitude test is admission test is on the 20th, and as as the notification does say, it will have it'll have two sections. It'll have one aptitude based section and a WAT, that's an essay section. So last week to go, I thought some of the topics that we could discuss here would be relevant. Besides the arithmetic session that we had, I thought we could sort of include a few topics that would probably be important for the IIM Rohtak exam, and even for some of the other exams that's going to come up. So today's topic, we're picking up three specific sort of question types. These are questions on clocks, questions on races, and questions on cubes, right? So very, very specific question types. These could come in the form of set. Maybe an LR set could come on either clocks or even cubes, or just a normal sort of question type. So that's what we'll be discussing today. I hope that you guys have received the exercise for today. If you haven't, if you're watching this for the first time and you need to access the exercise, click on the link in the description and quickly register, and the first class exercise you'll get the class exercise for free. Are you guys able to hear me? Can you give me a shout in the chat if you guys are able to follow me? All of you guys listening in live. Are you guys able to hear me? Can you let me know in the chat window if the audio is loud and clear? Great. Yes, good evening. Yes, good evening, guys. Notice something different? That it's kind of hard to miss. Yeah. I mean, most of you guys have been around with us for some time. Right. So let's get into the thick of things for today. We're doing. Yeah. Hi. Good evening, Kriti. Right. So let's begin with the first question type. This question type deals with clocks. Right. It's a question that comes either in the quant section or in the LR section, and it can get tricky, right? But it's a concept which is basically grounded in time, speed, and distance, right? You know that distance equal to speed into time. And so similarly, on a clock, the different hands are moving at different speeds, right? You have the minute hand, and usually we consider the hour hand, right? These are the two hands that we will focus on, and it's quite easy to see that the minute hand, it rotates, right? Now we will use the same formula, distance equal to speed into time, but the only sort of change we'll make is that we won't measure distance in the standard units. So here we'll measure distance in degrees. So think about a minute hand, right? What angle does it sweep? So any hand can go the entire 360 degrees and sweep the circle, right? So how long does the minute hand to sweep that 360 degree angle? It does so in 1 hour, right? That's 60 minutes. Whereas the hour hand is much slower, right? It's obviously not going to be able to complete one full rotation in 60 minutes. In fact, in 60 minutes, it only moves from 12 to 1 or from 1 to 2 or so on and so forth. So every 60 minutes, it only moves 1/12 or 30 degrees, right? But we can say that the entire 360 degrees would be covered in 12 hours. That's like 12 into 60 minutes, right? That's like, yeah. So you can see that the two hands can be thought of as two persons running around a circular track, right? And they seem to run around this circular track at different speeds. So can I analyze this motion, right, differently? Okay. So clearly, since we now know know their different speeds, we can calculate speed of the hour hand. Speed of the hour hand would then be distance in this much time. The speed will be distance upon time. So the speed of the minute hand becomes 360 upon 60. That's like 6 degrees per minute. Whereas the hour hand, divide distance by time, right? We're going to use this value of time. So it will become 360 divided by 12 into 60. Yeah, so 60 into 6 is 360 and 6 into 2 is 12, which basically becomes half a degree per minute. So we'll get the speed of the two hands, the minute hand and the hour hand, as 6 degrees per minute and half a degree per minute. So if I'm dealing with clocks, the fundamental block is to know that the minute and the hour hand run at different speeds, and these speeds are 6 degrees per minute and half a degree per minute. And you can also imagine this as 0.5, right? So either half a degree per minute and 6 degree per minute are the speeds, right? Right. Now, if this be the case, right, besides knowing these two salient facts about clocks, the other thing you need to know about a clock is that a clock has 12 hourly divisions. Everybody who wears a watch will know there are like these 12 divisions around the entire circle, and so if there are 12 divisions, these 12 divisions will correspond to the entire circumference or 360 degrees, right? So if 12 divisions correspond to 360 degrees, one division by unitary method will correspond to 360 by 12, 30 degrees, right? So I can very easily calculate angle on a circle. If both hands are on hourly divisions, we can very easily calculate the angle between the hands. Like for example, if I say what's the angle at 4 p.m., right? No problem. You'll say, okay, imagine 4 p.m. This is a clock. The minute hand is going to be at 12, and the hour hand is going to be at 4. So which means that it's going to sweep. The angle between them will sweep 4 divisions. So 4 divisions means 4 into 30, that's like 120 degrees. Yeah. So the first thing to know is that the hourly division on a clock, each hourly division corresponds to around 30 degrees. Yeah. So that's one. And we will make use of this, right? Instead of 4 p.m., if I, for example, said what's the angle at 8 p.m. Right? So again, at 8 p.m. you can imagine the way the hands are going to be lined up, right? It's going to be lined up like this, correct? So from this end you have 4 divisions, so that's 4 into 30 degrees, and from this end that's going to be 8 divisions, that's like 8 into 30 degrees. So you can say the angle is actually 120 degrees, but the reflex angle is the one that is swept by the minute hand. So the minute hand will move along an angle which is equal to 240 degrees. Right? So those are building blocks, right? So the 2 building blocks I need, again, let me repeat. 1, division between angle between any 2 successive hourly divisions is 30 degrees. So all I need to count is how many divisions, right, to get the angle between any 2. And number 2 is we need to remember the speeds of the 2 hands, right? 6 degrees per minute and 0.5 or half a degree per minute, right? Those are the two things you should remember. Okay, now let's look at some problems, right? Let's start with the exercise. I hope all of you have accessed it. Wow, somebody is noticing my haircut now. Thanks, Diya. Kab karwai? Well, it's been some time now. It's been about 3 days. It looks fresh, no? Yeah. I'm feeling a lot more comfortable now. Less hair to manage. Yeah, so can we guys open the class exercise for today? Sure you guys have it on your online accounts. We've also, if you don't have access to it, again, good point to tell you, click on the link below and register for the class exercise. You guys have that? Look at question number 1 over here. What is the angle between the minute and the hour hand of a clock when the time is 1:40? That's the first question. Right? How do I deal with this? How do I calculate the angle between the hands at 1:40? Yeah, so here's the way you should think about it, right? At 1 o'clock, this is the way. So what you do is whenever a time is given, you ignore the minutes on the clock, right? You forget 40, right? And go back to the rounded off time, right? Which means 1 p.m. So here, if it's 1 p.m., this is how it's gonna, you can imagine this. The minute hand is going to be at 12, the hour hand is going to be at 1, which means to begin with, at 1 o'clock, the angle between the 2 hands will be 1 division. Between 12 and 1 is 1 division. So that's going to be 30 degrees, right? So I know that the clock started with the minute hand and the hour hand 30 degrees apart, right? Now, what happens when the clock runs up all the way till 1:40, right? So now while you can draw a diagram, but if you imagine, right, the minute hand will basically overtake the hour hand, and then it'll go, keep on going all the way till it reaches 1:40, right? Roughly about here, right? That's where the minute hand will finish at 1:40. Will the hour hand be stationary though? Is the hour hand going to stop, moving? Obviously not. We all wear watches. We've all observed how, they look between 1 and 2. So it's not going to be stable at 1 o'clock. It's in fact going to move closer and closer and closer to 2 o'clock. And so I can imagine that at 1:40, while the minute hand will be here, the hour hand will have inched very close to the second division, right? So this is 12, this is 1 and this is 2. At 1:40, roughly I can imagine the hands to be in this position, right? You don't actually need to draw. I'm just trying to use it to explain what approach we will follow, right? Now, if I want to use the logic of distance, speed and time, this is like two runners, both of whom are running. This guy is also running and this guy is also running, but they do so at different speeds, right? The hour hand runs at half a degree per minute and the minute hand runs at 6 degrees per minute, right? Now, one way is to let both the runners move, right? And see what happens, right? Like, for example, what I could do is I could say, okay, what angle does the hour hand, minute hand cover, right? So the minute hand moves at 6 degrees per minute. So distance covered by the minute hand will be his speed of 6 into how long? 40 minutes, right? So the minute hand will move from its original position, right, which was here. You need to mark the original position and say, okay, this angle swept will be 240 degrees, right? I could do that. And then what is the distance covered by the hour hand? That's going to be at a speed of half a degree per minute. This hand moves for 40 minutes. So that's going to be an angle of 20 degrees. So if this was indeed the original position at 1, then the angle swept by it would be 20 degrees, right? And now, if you want this angle, right, the angle between the final position of the minute and the hour hand, you can directly say, okay, originally if this was 30 degrees, I know that from 30, the movement of the, sorry, this wasn't 30. This was 30, right? Yeah. So from 30 degrees, the movement of the hour hand increased it by 20 degrees, correct? So if the minute hand had been staying here, the hour hand moves here, that would have increased the angle and it would have become 50. But then the minute hand, when it moves, it first closes out 50 and then covers the remaining 190 degrees. So I can say 30 plus 20 minus 240, right? I don't know if it makes sense to you, right? But the idea is to figure out using the diagram itself what will the final angle be, right? But it usually ये थोड़ा सा complicated हो जाता है. It turns out to be a little confusing to work with. So I have a better approach, right? The better approach I have is to not do any of this, right? The better approach I have is like a straightforward approach. We'll say final angle will always be equal to initial angle minus the relative speed of minute hand with respect to the hour hand into time, right? This is a formula I can use, right? I can always use this result to get an answer, right? किसी भी clock के question में, whenever you need to find the angle between the two hands of a clock, I can directly use this formula, right? But remember, here angles are measured in clockwise direction. Please remind yourself, if I'm measuring the angle, I will always measure it clockwise. I will never measure it anti-clockwise, right? So if I want to measure this angle, I'll say 30 degrees. But if, for example, the time were indeed 8 o'clock, then the angle between them will not be measured in the anti-clockwise direction. You'll have to measure in the clockwise direction. So you'll say that angle is 240 degrees. So make sure that when you're dealing with this formula, using this formula, you'll only measure angle in clockwise direction. So let's do that. At 1 o'clock, the initial angle would be 30 degrees when measured clockwise. What is the relative speed of the two hands, right? Well, you know the individual speeds of the two hands. Since they move, both hands move clockwise, they move in the same direction. So relative speed should be the difference of the speeds. So that's going to be 6 minus half a degrees per minute. This is the relative speed, A minus B, into time taken. How long did they move? They moved for 40 minutes. So there you go. That should be your answer. 30. Yeah. 30 minus 6 to the 12 minus 1, 11 by 2 into 40. Knocking it off, I'll get 20. 11 into 20 is 220. So 30 minus 220 gives me minus 190. And is this relevant? Absolutely. This is, देखो ऐसा, I can't say with, DU-JAT just having 20, 25 questions in the quant section. Can't really say if, clocks will come for certain or not. I don't think I can ever say with certainty whether clocks will come in DU-JAT or even in IPM, right? But what I can say, it's a different kind of question, and it's one, which you will be, if it comes in the exam, you will be really surprised. So I think it's relevant for both DU-JAT and IPM. So final angle between the two hands will then become negative of 190. Remember, why is it negative? Because now you're saying that the angle, initially when you measured the angle in the clockwise direction, which hand was behind? The minute hand, right? But finally at 140, if you imagine the two hands, which hand is now behind? If I measure it clockwise, this is the angle I'm measuring, right? But if this is 190 degrees, then which hand is behind? The minute hand is ahead. The hour hand is actually behind. So since the orientation of the hands changes, the angle is becoming negative, right? But for all practical purposes, you'll say angle is 190 degrees. Is this clear to everybody? How did this happen? How did I get negative of 190? Yeah, you just say initial angle, measure it. Hourly divisions ke logic se, if it is 140, I'll go back and say make it 1 o'clock. At 1 o'clock, the angle between the hands, will cover one division. One division is 30 degrees. So initially you'll start with 30 degrees and then subtract the angle swept at relative speed. At relative speed here will be 6 minus half. That's 5.5 degrees per minute. And you multiply this 5.5 with the relative speed. Right? That's about 40 minutes. Well, some of you are asking me about the IPM pattern, yeah, the new pattern. I'm sure that you guys got the mail from IIM Rohtak. Did you guys get an email from them? Right. So in the new pattern, there, the first section that you have is a multiple choice section, and it has about, I think it has about 60 questions that you need to solve in 45 minutes. So it's a section where time will be a problem, right? Timing is going to be a problem. Well, the pattern clearly states it will have all three sections, quant, logic, and verbal. But 60 minutes in, and I believe that the sections will have equal weightage. So expect to get 20 questions each from English, math, and logical reasoning. So 20 questions in 1/3 the time, that's 15 minutes. I don't know if 20 minutes will suffice for 15 math questions. You shouldn't even try to do all 15, right? So again, the idea, try to do all 20. So the idea is that make sure that you pick and choose questions wisely. Be very, very careful when you're attempting the test. I hear from reliable sources that this could also be a test administered straight away as a Google form also, right? It could just be a Google form that you guys will need to sort of take the assessment as. So I don't think there will be any higher math question. If at all, there might be maybe one or two of them, right? So very right, Hardik. The new pattern, given that it's a 45-minute test, I think the first section at least will not contain too much of higher math. So basic math, I think maybe the level might be slightly harder, but it should be stuff which you have already studied, that we've already covered in the program so far. So itna mushkil nahi hona chahiye. It shouldn't be very hard, right? But I think question selection becomes critical. Make sure that you do justice to all three sections, right? Make sure that verbal, you score as much as you can, because I believe that the verbal section should be the most scoring amongst the three, followed by logic, and then finally by English, then finally by quant. So clearly the scoring section being verbal, make sure that you do well at it, make sure that you allot enough time and complete it, attempt all questions from verbal, right? So that's, that's the first section, 45 minutes. Once that section gets completed, there's a short break. I think they allow you to sort of go get some water, freshen up a little bit. And then you need to write a WAT, that's an essay, right? So short essay on a given topic. Topics could be, I don't think that the topic should be very, very vague. It could be about, something about the current sort of scenario, maybe about technology, maybe about the pandemic response, maybe, what this has meant for businesses all over the world, maybe, your thoughts on how, different strata of people, how maybe a, sociological study of the pandemic's effect, right? So yeah, it should be, I mean, make sure that for the next week, you guys must be reading the newspapers. Make sure that you regularly read newspapers, editorials, and get some practice on the WAT. Remember, we had one session we did on how to handle the WAT section. I am going to plan another session on the WAT very, very soon, before 20th. So today is already 14th. So my hunch is we probably do something maybe on Friday, right? So that's something that I've planned specifically for IIM Rohtak, right? But yeah, I mean, I don't think it makes much of a difference. It's a 1 hour test. Sorry, it's a 45-minute MCQ test, which should be quite similar to any practice test that you've taken, right? I know it's now a shorter test. I don't think cutoffs will be drastically different any which ways, right? I still think that your aim should be scoring about 35 marks or 36 marks in the test. And if you could do that, then you're really putting yourself in a strong position, right? So yeah, that's about the. Did you have any specific questions for me, Hardik, or does that make do? Yeah, looks like Hardik, is satisfied with that answer. Okay, let's move things ahead, right? So question number 1, हमने इस formula से question number 1 we've solved. Why don't you guys try your hand at the second one, right? Not question number 1, but the second part to that question, right? Find the angle at 6:30. Can you guys try doing that? (6:30). What's the angle between the hands? Yeah, absolutely. I have a very quick answer by Hardik, but it's a very obvious one. I think all of you should be able to get this. Superb, right? So if I substitute, since the time given to me now was 6:30, so we'll say, okay, let's rewind, go back to 6 o'clock. At 6 o'clock, I can imagine that the hour hand will be at 12 and the minute hand will be at 12 and the hour hand will be at 6. So the initial angle between the hands should actually be 180 degrees, right? And relative speed is constant. That's going to be 5.5 or 11/2. I remember 11/2. I think if you can sort of keep that in mind, it becomes very easy. And how long does the minute hand move? Well, do the hands move? They move for 30 minutes. So 11 by 2 into 30, right? So I end up getting 180 minus 11 by 2 into 30. 15 into 11 is 165. So 180 less 165 is 15 degrees. Right? So the angle between the hands is 15 degrees. Okay, next one. 3 and 4. Try both of them now. Try questions 3 and 4. I mean, parts 3 and 4 to first question. Okay, I got a quick answer to this one too. Nice. Looks like most of you guys are getting this. Yeah? Straightforward. No, if I use this formula, it's a very straightforward question, right? At 4 p.m., I'll say for angle at 4:45, we'll say initial angle would be at 4 o'clock. At 4 o'clock, that's 4 divisions. 4 divisions means 4 into 30 degrees. So that's going to be the initial angle minus 5.5 degrees. I can write that as 11 by 2 into how long? 45 minutes. Right? So that's going to be 120 minus 45 into 11 is 495. 495 by 2 is like 247.5. So 120 minus 247.5 gives me negative 127.5. Obviously, you will ignore the negative sign. The answer will be 127.5, right? And likewise, I think the last question, angle at, find the angle at 825, right? So if you want angle at 825, so you'll say, okay, let's go back, run it back to 8. At 8 o'clock, the angle between the hands. Right? Now, this is going to be slightly different. You'll measure the clockwise angle. So you'll measure 8 divisions. So that's 8 into 30, 240 degrees. Minus 11 by 2, the relative speed, into time, 25 minutes. So 25 into 11 is 220, 275 divided by 2. So 240 less, how much is this? 137.5. Clearly, 102.5. Right? So parts 3 and 4, I hope first question everybody got this, right? Pretty straightforward sort of approach. If I use this formula, yeah, in fact, for most questions we will tend to use this formula on, especially if it's a question on clocks. Yeah. Okay, this one is easy. How about the next one, question number 12? At what time between 4 and 5 will the hands of a clock coincide? Okay, so it asks me to find at what time do the hands coincide, which means the minute hand has to be on top of the hour hand. When does that happen, right? So how do I know? Again, it's a question you could solve by using the same approach, right? You say, okay, final angle, whenever, at whatever time it is, the hands must coincide, right? And the question says, at what time, right? So which means you want to find the value of time. You know the relative speed. You know initial angle, right? Because it says between 4 and 5, initial angle will be at 4 o'clock. Right? So again, I know the initial angle. What do you want the final angle to be? Since the hands are now coinciding, the final angle is 0. So for question number 2, right? For question number 2, we'll still use the same formula, but you'll say final angle should be 0. Initial angle at 4 o'clock is 4 into 30 degrees. And you want after how long, let's say t minutes later, the angle becomes 0, right? So I can solve this equation to get the value of t, right? So in the previous question, you know how long it runs, so you could find the final angle. But now you know the final angle needs to be 0. So let's see how long it needs to run, right? So bring in that here and equating, you'll get t as 120 into 2 by 11. That's like 240 by 11. That's like 22. 11 2s are 22. 20. 11 1 is 11. So that's 21 9 by 11 minutes. Remember, we're dealing with speeds in degrees per minute, so time will be in minutes, right? So 21 and 9 by 11 minutes. But I can see if I look at the options, three choices are for 21 and something, right? So I need to be a little more precise, right? So 21 minutes works, but the 9 by 11, you'll have to convert the fraction into seconds. So 9 by 11, if I convert minutes into seconds, I multiply by 60. So that's going to be 540 by 11. That's going to be slightly less than 50 seconds. So answer is going to be 21 minutes and slightly less than 50 seconds. And I can see option C is perfect. 421 and 49 seconds is very, very close to 450, right? So that's when the hands of the clock will coincide, right? Very, very straightforward. So if I need to find the angle at a particular time or time taken to coincide, I can directly use one formula for it. Yeah. Okay, so these were basic questions, very, very simple question types. Should be able to figure out, right? Let's shake things up a little, right? Let's look at different other kinds of questions. How about question number 3? How many times, and let's see if you can figure it out, right? Let me give you a minute and you guys try question number 3. How many times do hands of a clock coincide in a single day? In one day, how many times do the hands of the clock coincide? If this is what coinciding means, one hand being on top of the other, how many times will it happen in an entire day? Right? Let you think for it. Think about it for a minute. I'm going to be back in a sec, guys. Okay, I have one answer. And Han says 22. How many times will the hands of a clock coincide in an entire day? Right? But if you're wearing watches, this is not a very hard question. Yeah, you can actually figure this out by even logic, right? Like for example, it's 12, right? Between 12 and 1, how many times do they coincide? So imagine this. When will they coincide? At around, actually between 12 and 1, they won't ever coincide, right? Because the hour hand is at 12, the minute hand overtakes, sweeps and comes back to 12, and the minute hand, it won't touch the minute hand. So when will it touch the minute hand? At around 1:05, maybe 1:06. Yeah. And the next time it will coincide again, after 1:05, it will coincide again at 2:10. And so you can see that it happens, it takes slightly more than an hour for the hands to coincide, right? So if it takes slightly more than an hour, it can't be 24. Option D is ruled out. It cannot be 24. Yeah. So I'm left with either 20, 21, 22 as viable choices, right? And again, you can see if you count also like this, right? 1:05, 2:10, approximately 3:17, 3:15, 4:20 or so, 5:30 or so, 5:25 or so, 6:30 or so, 7:35, 8:40. Remember, I'm not saying it coincides at 8:40, close to 8:40. And then 9:45, and then 10:50, that's 10. And then after 10:50, I'm going to say at 12. Yeah, so that's 11 times in one full rotation, right? So another 11 times makes it 22. So you can count it. Physically, you could sort of figure it out without using any calculations, right? But you need to know the calculations, because this kind of question can have many variations, right? So the way you do this calculation is you say, let's say that the initial time is 12. Right? The time now is 12 o'clock, right? So after how long, after how much time will the hands again go inside? Because at 12 o'clock the hands are together. So at, let's find the interval when they coincide again. So again, I'll use the same formula. I'll say initial angle is 0, right? And the final angle should become 300, right? I can put 0, but in this case, I'm going to put 360. In fact, you'll probably do the reverse, right? Instead of making both of them as 0, you'll put this as 0 and you'll say this has 360 degrees. Absolutely, that's what I'm doing. Minus 11 by 2 into t, right? So if I use the same formula again, I'll say, okay, the initial angle was 360 degrees, and now that 360 degrees will become 0, right? One of them will have to be 0 and the other has to be 360 degrees. Either way, you'll get time as 360 degrees divided by 11 into 2. How much is this, right? You don't really need to calculate, just leave this. 720 by 11 minutes. Agar मैं इसको calculate करता हूँ, if I find this out, 11 6 are 66, 60, 11 5 are 55, 65, 5 by 11 minutes, right? And 5 by 11 is slightly less than half a minute. So about 65 and a half, right? So roughly 65 and a half minutes, that's the interval at which they coincide, right? It's like saying that I eat a toffee every 5 minutes. So how many toffees will I eat in an hour? So you'll say, okay, if I eat it every 5 minutes and I eat n toffees, the time I'll take to eat n toffees will be 5n, right? And if this is 1 hour, I'll say 5n equal to 60 and say n is equal to 12, right? Same way, if the hands of a clock coincide every 65 minutes and they coincide n times in a day, then this time 720 by 11 into the number of times they coincide should make one full day, right? That's 24 hours or 24 into 60 minutes, right? So this is the way that I'll solve and get the value of n. Yeah, that's exactly what you've done. Again, नाम आपका तो studio yoga दिख रहा है यार, मुझे नहीं पता. I don't know what to call you, but Mr. Yoga here has also done exactly this, right? So I can then get the value of n, right? The logic behind this formula is they coincide every 65 minutes. The hands coincide every 65 minutes or 720 by 11 minutes. And if they coincide n times, it will take them this much time, right? And this should be done in one full day, right? That's 24 into 60 minutes, right? So equating it, you'll get the value of n as 24 into 60 divided by 720 into 11. So 16, knock the 0, 6 into 12, 12 into 2, you'll see the value is directly 22. Exactly 22 is what I get. Okay, Raghav. Okay. So Raghav has done exactly this, and Raghav, you're right. You could indeed solve this question in this manner, right? I hope that it makes sense to you. How many times do they coincide? No problem. Let's calculate the interval between them coinciding and multiply that with n to get a full day, right? And you can see this question also has many variations, right? And if you follow through the exercise, see many questions like this. Like question number 4, right? Variation. At what time between 9 and 10 will the hands be in a straight line? Again, question gives you a hint, right? So I'll start at 9 o'clock. Initial angle is at 9. At 9 o'clock, the angle is going to be 9 divisions, right? Imagine this. This is what 9 I'll measure. Initial angle as 9 into 30. 9 divisions. 9 into 30, 270 degrees minus relative speed is 11 by 2, right? And it says at what time will they be in a straight line? What is the final angle? If the hands are in a straight line, what is the angle between the two hands? So if it's a straight line, angle between the two hands will become 180. So you want it to be 180 from 270 degrees, which means it will have to reduce by 90 degrees. It reduces the rate of relative speed, which is 11 by 2 into time t. Solve karo, time nikalo. Yeah. Question number 4, I solved it in one step, right? So if I use that, answer to question number 4 will become 180 is equal to 270 minus 11 by 2 into t. So t will become 90 into 2 by 11. That's like 180 upon 11. That's like 11 ones are 11. 70 left, 11 6 are 66, 4 left. So 16 4/11th of a minute, right? Does that suffice? 916 won't suffice. There are two options saying 916, right? So, which means I'll have to convert this into seconds. So 16 minutes and 4 upon 11 into 60. That's like 240 by 11. 11 twos are 22. 11 ones are 11. So it will become 16 minutes and 21 seconds. That's option C. So the answer to question number 4 is option C. I hope that this is all making sense to you guys. Please give me a big shout here in the chat if you guys are following. Okay, great. What I'm going to do is I'm going to let you try the next few questions yourself, right? Let you guys try question number, 4th, 5th, even 6th. Let's instead do question number 7, right? Let's discuss question number 7. Can you try question number 7? Tell me what you get. How many times between 12 a.m. and 12 p.m.? How many times between 12 a.m. and 12 p.m. are the hands perpendicular to each other? Come on. IPM aspirants, come on. Give me an answer. Okay. One super quick answer from Mohit. Okay, Arushi agrees. But the rest of you guys, do it exactly like question number 3. Can you? By the way, I forgot to ask. Oh, most interesting. Yeah, you guys are board results are out, right? ICBSE, ISA, everything is out. Everything is done and dusted. Yeah, I think negative marking stays. Yeah. How did you guys do in boards? Kaisa raha yaar? How did you guys perform in? Happy, sad? I hope everybody is happy. यार सब खुश रह रहा है यार please. मतलब no need to have negative vibes कि नहीं 5% और कम आ सकते थे, ज़्यादा आ सकते थे. I could have scored a 90 in math, or I could should have scored a 95 in accounts, or whatever it is that you have, right? So bygones be bygones. जो भी किया आपने, you've done well, right? And I'm sure marks are not a reflection of your ability, but make sure that it motivates you to work harder. And I certainly hope that a lot of you are motivated enough to work and get into IIM-Indore, IIM Rohtak, or DU-JAT. Yeah, one of these fancy places to study. Absolutely, man. So how do we do this? Question number 7, right? How do I do? Question number 7. Now the thing about question number 7 is that it says between 12 a.m. and 12 p.m. So initial has now been fixed 12 a.m., right? So initial time has been fixed, right? So I'll imagine it to be 12, right? And the question asks me to find how many times that the hands are at perpendicular to each other, at right angles, right? So if the hands are perpendicular, I know that it's going to be somewhere around 12:15. 12:15 so thoda sa zyada hoga, right? Because the minute hand, our hand will also move, na? So it won't be 12:15, but it will be close to it, right? So which means that you want the final angle to be 90, whereas the initial angle is 0, right? And you want it to, ideally you should say minus 11/2 into t, right? So if I solve, I'll get t, right? 90 into 2, 180. Negative aayega, obviously, 180 upon 11 is the time taken. So ignore the negative sign and say, okay, it's going to take about 16 minutes, right? So 11:16, fair enough. But then, can I take this as the interval between, every 16 minutes they will be perpendicular? Ek baar gaur karo, what is the time after, this is 16, 4/11 minutes, right? So 16 and a half or something like that, right? So about 16 and a half minutes means time will be 12, 16 and a half. After another 16 and a half minutes, the time will become 12:30. 12:32, maybe 12:33. So if it's 12:32 and something, are the hands perpendicular? They're actually not. So you can't say every 16, 4/11 minutes they coincide. In fact, the logic here is, in the previous case, we could do that. In question number 3, you could do that because it started together and it finishes together, right? So start and finish have to be identical for you to use it as an interval, as a time interval. Here, the start is at together, but finish is perpendicular, which means I'll have to again start here and take it to another point where it's perpendicular. Can you imagine this? Roughly 12:50 or so, the hands will again be perpendicular, which means now I'll say, okay, this is T1, right? Think of this as T1, right? After which it becomes perpendicular. And then at a T2, it will start at, so one of them will be 90 and the other one will be 270. Yeah. So from 90, it should become 270. So 270, and I know that I can't do 270 equal to 90 minus something. So I'd rather do 90 is equal to 270 minus 5.5 t. Yeah. So basically you'll end up getting 180 is equal to 11/2 into t, which gives me the value of t as 360/11, right? And you can see that this is almost double. exactly double actually. Right? So if they coincide, if they are perpendicular after 16 minutes, then after 32 minutes they will again be perpendicular. And now I can keep using this as an interval. T2 will be an interval. Every 32 minutes, the hands will become perpendicular to each other. Let's test it out. So 12:15, and then 32 minutes, 12:45, and then 32 minutes, 16 means, so 12:16, and then after 32 minutes, it will become 12:48. So 12:48, and then after another 32 minutes, it will become 12:50 and 1:20. Right? So it will become 120. Yeah, there you go. Angles are again perpendicular. So every 32 minutes, the hands will end up being perpendicular. So so the way you'll work this out is you'll say, okay, make an inequality like this, right? You'll say, if T1 is the first time that it becomes perpendicular, and then every 32 minutes, if it becomes perpendicular, let's say that happens n times. This should either be equal to, 12 hours. But if it's not equal, it should be less than it, right? It can't be more than 12 hours, right? So n times, if it coincides, it can't be more than 12, right? So you'll end up saying T1 plus, so let's substitute values, 180 by 11 plus n into 360 by 11 should be less than or equal to 12 into 60. And you can simplify this, 60 into 6, 60 into 3, 3 2s are 6, 3 4s are 12. So if I simplify this equation, inequality rather, I'll end up getting 1 plus 2n. Take the 11 there. Positive value does not change anything. So 11 into 4, 44. Which means 2n must be less than equal to 43. Which means n must be less than equal to 21 and a half. So which is an integer value which is less than 21 and a half? 21. So I should mark 21? No. That's where you'll go wrong. If you mark 21, that would be incorrect, because the answer is not 21. The answer is actually, because 21 more times after the first meeting, after they first become perpendicular. So total is equal to 1 plus the 21, 22 times. So how many times are the hands of a clock perpendicular in 12 hours, from 12 a.m. to 12 p.m.? 22 times. Does that make sense to everybody? Can everybody sort of imagine this? What I've done is, first, from 12 a.m., when will it become 90 degrees? It will take this much time. Then from 12:15, if it needs to become perpendicular again, it will need to sweep from 270, it will become 90. Right? So it will take how much time? It will take 360 by 11. So first time it will take this much time, and then after taking this much time, every T2 minutes it will become perpendicular again. So T1 plus n times, if it becomes perpendicular n more times. So n more times will take n into T2 minutes. So T1 first time plus the next n times in total should take either 12 hours or less than it. And if I solve it, the maximum value of n I get is 21, integer value obviously. So if 21 more times it will become perpendicular, means in total it will become perpendicular 22 times. I hope that everybody is clear with this, right? Do you have any questions? Please ask me. Is everybody clear with this? Yeah, okay. You're either clear or or just sort of wary of this question type, right? From this point, questions will become harder, right? Then the level of questions will become slightly more application based, right? So इसके आगे के questions exam में आएंगे छोड़ देना, right? I don't think especially in IIM Rohtak, you have the luxury of time to be trying out a new type of question, right? So everything from this point onwards, you can actually ignore. In fact, maybe we can do a few questions in there, but in a broad sense, I'd say. Yeah, I can't really say, Anand. I can't really say. The questions like these, मतलब ये 90 degrees वाला आता है, straight line वाला आता है, and coincide वाला आता है. So yeah, in at least these three cases, what you're saying is actually correct, right? That it will either be 22 or 44. So most of the time it is like that. Yeah. Okay, let's look at a few more questions on watch. I won't discuss all of them. Like look at question number 8. Ram checks the time twice in 1 hour and notices that the hands have interchanged. So what was the interval between the 2 times that he checked time? Please understand, read the question, understand. The hands of the clock need to, they exchange places. Yeah. Again, in itself, not very hard, but in an exam situation, I'm not sure if you, will be able to understand the question, right? It's not the easiest of questions to sort of understand. What does it mean? The question says ki the hands of a clock, right, exchange places when Ram checks time 2 times in the same hour, right? So 2 things he's saying. He checks time twice. But both of these happen within 1 hour, within 60 minutes. So basically, the clock runs for about 50 odd minutes or maybe 40 odd minutes, something less than 60 minutes. And in that time, wherever the minute hand was, the hour hand goes there. And wherever the hour hand was, the minute hand goes there, right? So imagine this. So they must be clearly close together, right? Must be something like this, right? Or maybe something like this. Yeah. In fact, what I can say is this can't be the right way, right? Because the minute hand has to be in front. The minute hand has to be ahead of the hour hand. It'll be probably like this. Can you see this? If this moves from here and comes here, right? By the time the minute hand comes in this position, the hour hand would have also moved some distance, right? So starting from here, the clock will run and it will now show the hands like this. So the question says that if this happens, then what was the interval between the two times that he checked? Essentially, how long did the clock take? That's to go from this position to this position. So what you can do here is what you should notice is that I don't know the angle between the hands, right? So let's say that angle is theta. So theta is the angle covered by which hand? Those of you attending live, can you let me know in the chat? This angle theta will be covered by which of the two hands? Which of the two hands will move a distance of an angle of theta degrees on the clock? I don't know if there's a lag, but you guys seem to be answering pretty slow today. Entu kam hai kya? Kya ho gaya? No. How will the minute hand sweep theta? Monica. The minute hand will actually sweep the reflex angle, right? Because it's already in front. It'll actually be the R hand, which is behind, which will move clockwise, right? So the R hand moves theta degrees, whereas the minute hand moves. Can you tell me what distance does the minute hand cover then? If the R hand moves theta, then Raghav and Arhan and Kriti and Onika, can you guys tell me what is the distance or the angle that will be covered by the minute hand? Perfect, right? So obviously it's going to cover the remaining angle. So this is the minute hand which will move 360 minus theta. Okay. But interestingly, these will be distances covered by the two hands in the same time. And in fact, that is the question. How long does it take for this to happen, right? So you don't want theta actually. You want time, right? But interestingly, the time is the same, right? Because both hands move for the same time, which basically says if time taken is the same, let's say this time taken is t minutes, then the distance covered by the R hand will be half a degree per minute. So basically, you'll say distance equal to distance covered by the minute hand is equal to 360 minus theta, and distance covered by the R hand is theta, right? But I also know that distance is equal to speed into time. So minute hand moves at a speed of 6 degrees per minute, and it moves for how long? T minutes. Whereas the R hand moves at a speed of half a degree per minute, or let me write 0.5 for now. And it also moves for t minutes. So then these distances covered will actually be 60 and 0.5 t. So what I can do is I can simply eliminate theta. So theta की जगह ये substitute कर देते हैं. By solving these together, you'll end up getting 360 minus 0.5 t should be equal to 6 into t, which means 360 will be equal to 6.5 t, which means t will be 360 into 10 by 65. There you go. That's your answer. 5 into 13, 5 into 2. So I end up getting 720 by 13 minutes. This is how long it will take. 13 5s are 65. 7 बच गया 70, 13 5s are 65, 5 बचेगा. So 55 and 5 by 11 minutes is the interval between the two times that this person, what's his name, Ram, must have checked his watch, right? So Ram checked his watch 55 minutes after he checked it the first time. The second time he checks will be 55 and a half minutes, or 55 5 by 11 minutes after the first time he checks. And is that there in the options? 55 and something? Indeed, option B has to be the correct choice, right? So 55 minutes and 23 seconds is the right answer. Is this clear to everybody? You guys get this? You guys seem to be in shock, man. Yeah, let you see the board. Right? It's once you figure it out, it's not so hard. No, you know, minute hand covers 360 minus theta, R hand moves theta, and these distances are covered at same time. So if I do distance equal to speed into time, distance equal to speed into time, and solve it simultaneously, I can calculate both theta and t. Yeah? The logic here is the minute hand moves. I know that the sum of distances traveled by minute and the hour hand should be 360 degrees. That's one other way of looking at it. If the hands exchange places, then the distance covered by the minute hand will be the reflex of the angle covered by the hour hand, which means the sum of distances covered should be 360 degrees. So 360 degrees should be the sum of distances covered. So it will be equal to 60 plus 0.5 t. That's 6.5 t. Right? So that's how I get here. Right? But I've shown it, you know, in steps here, and I hope that it makes sense to you guys. The logic here is that in the same time, let's say t minutes, the hour hand will move an angle of theta and the minute hand will move an angle of 360 minus theta. Right? The hour hand will move from here to here. Right? Let me maybe take 2 pens and explain this to you. Right? So if you know this is the minute hand and this is the hour hand, the hour hand will move the entire 360 degrees and the minute hand will move 360 degrees minus x and the hour hand will simply move theta. Yeah? So in the same time, if these are the distances, I simply do distance equal to speed into time and distance equal to speed into time and then solve it simultaneously. In दोनों equations को solve करके t निकालना है. After this, it's a question on linear equation. It's knowing how to solve a linear equation, a pair of linear equations. Two variables unknown. Solve कर लो. Is this clear to all? Please acknowledge, guys. If you know there's still confusion, let me know. But if you guys understand, you don't need to retract messages, Raghav. Asking me to explain again is a good thing, right? So don't need to retract and delete and all of that, right? Let it be. Yeah. But I hope that the rest of you are understanding this. Yeah. Okay, that's great. Okay, I'm going to discuss one more question. In fact, I'm going to give you 2 questions to try. Yeah? Okay, I want you to try question number 10. See if you understand this. This is a tricky problem. Right? But if you understand the question, the answer is not that hard. So try question number 10. And for us to understand the next topic, I want you also to try question number 13. Right? So question number 10 and question number 13, I'm going to give you a couple of minutes each. And see you at the end of 2 minutes, right? So I'll be back. I want you guys to try this. Yes, so 10th question, did you guys get an answer? Did you manage to solve question number 10, guys? Let's see how. Right, so this one says that a watch gains 4 minutes every hour. So pause here. What does that mean? So if a clock gains 4 minutes every hour, if this clock was, initially set at 12 o'clock, then after 1 hour, if I look at this clock, what will it show? What time will it show? So it won't show me 1 p.m. It will show me it will run 4 more minutes. It gains 4 minutes. So it will run 4 more minutes, which means it will show 1-4. That's what it means, right? So first of all, I hope you guys understand what it means when a clock gains time. It will run 4 more minutes for every hour. So instead of running 60 minutes, it will run 64. In 60 minutes, the clock will run 64 minutes. So 60 minutes of actual time will lead to a faulty run of 64 minutes. That's what this means, this information means. So it says that this clock was set to show the correct time at 4 p.m. on a Sunday afternoon. Okay, so Sunday 4 p.m. the clock is correct, right? And then it will start running faulty, right? So the question says, when will it show the correct time again, right? Now the idea behind this is to imagine how much time does it need to gain so that the clock shows the correct time, right? Imagine this. So it gains 4 minutes, then it will gain 8, 4 more minutes, then it will gain 4 more minutes, keeps on gaining time, right? So the gap between the faulty time shown and the actual time shown will keep on increasing. But at some point, that increase will become 12 hours. The moment the clock gains 12 hours, imagine at 12 o'clock, if a clock gains 12 hours, if you keep running the clock for 12 hours, what will the time be? It will come back to 12. So the moment the clock gains 12 hours, so you want the gain to be, the time gained must be equal to 12 hours. That's like 12 into, excuse me, 12 into 60 minutes. So the question is, if the clock needs to gain this much time, how long will it take? So what you do know is that in 4 minutes, in 1 hour, that's 60 minutes, the clock gains 4. So the question is, how long? If in t minutes, the gain is 12 into 60 minutes, then what is the value of t? Unitary method. You can use unitary method if it gains 4 minutes for every 60 minutes. Then how long will it take to gain this much time? Unitary method lagate. If I use unitary method on this, I'll say, okay, then for it to gain 1 minute, it will take 60 upon 4. That's 15 minutes, which means for it to gain 12 into 60 minutes. How long will it take? 15 into 12 into 60. How much is this? 15 into 12 is 180. 180 into 60 is 1080. Sorry, 10,800 minutes. Right? So this is how much time it will take, right? So now let's work with this time. 10,800. That's like, in fact, let me write it as 180 into 60 only. 180 into 60 minutes will be 180 into 60 divided by 16 hours, which means it will take 180 hours. 180 hours can be thought of as 24 times how many days, right? Each day is 24 hours. So 24 into how much? So 24 into 6 is 144. 24 into 7 will be 162. So 24 into 7 plus 12 hours, right? Which means 7 days and 12 hours, right? So in 7 days and 12 hours, the clock will gain 12 hours and it will show the correct time all over again, right? So how long did it take? 7 days and 12 hours. So if the clock was correct on Sunday at 4 p.m., then after 7 days, the time will again become 4 p.m. and another 12 hours, it will show 4 a.m. on Monday. So the correct time will be shown at 4 a.m. on Monday. That's option D. So the answer to this question is option D, 4 a.m. on Monday. Absolutely, Krithi. Yeah. So is this clear? It's actually a question on unitary method. If it gains 4 minutes, the trick was to figure out that to show the correct time again, it will need to gain 12 full hours, which means 12 into 60 minutes. So unitary method lagaiye and see how much time it will take in order to gain this much time, right? Unitary method says 1 minute will, if 4 minutes takes 60 minutes, then 1 minute will take 1/4, 15 minutes. And if 1 minute takes this much time, then this 12 into 60 minutes will take this into 12 into 60. This is in minutes, 180 into 60 minutes. I converted this into hours and then I converted it into days and hours. So 7 days and 12 hours, and that shows the correct time. Okay, Raghav is asking me, how is it that it will show the correct time? Remember, it's an analog watch. It's an analog watch, right? If you're holding a watch, if you're wearing a watch right now, the time on your watch will be 7:30, right? If I turn the dial, even though there's a dial on the right? There's a button on the knob on the right, which allows you to fast forward time on your clock, on your watch. So if you fast forward it, right, how much will you need to fast forward so that it comes back to 7:30? Think about it. If it's 7:30 right now, how much will you need to fast forward so that it comes back to 7:30? You need to fast forward 12 hours, right? So it keeps on gaining, but once the gain becomes one full, 12-hour cycle, it will come back to the same time. Does that answer your question, Raghav? If my clock is set at a particular time, if I rotate the knob so that it runs another 12 hours, it will come back and show the same time all over again, right? Remember, we're using an analog watch. Day ka count nahi dikhayega watch. The watch will not show me which day is the time showing. It will obviously, after gaining 12 hours, it's actually saying the time is 4 p.m. Actually, time is not showing 4 p.m. The time is showing 4 a.m. on Monday. But on an analog watch, 4 a.m. and 4 p.m. are exactly the same. So it will show 4. And if you read the watch, it will seem like it's showing the correct time. Okay, let's move on. Next up, question number 13. I asked you to do question number 13, right? Question on races, right? I'll quickly, we've covered this in class. We've covered this even in the arithmetic session. So I'll leave you guys to try most of these questions yourself. But we'll quickly discuss a few, right? Question number 13 is slightly different from the usual variety. Okay, what does this one say? In a 2-kilometer race, Ravi beats Sandeep by 45 seconds. So R beats S by 45 seconds. And it also says Sandeep beats Tarun by 75 seconds, right? So let's understand what the first statement means. First statement means that Ravi finishes the race and Sandeep is some distance behind him. So Sandeep will take another 45 seconds to reach the finish line, right? And when Sandeep reaches the finish line, Tarun is some distance behind him. So he'll take another 75 seconds to reach the finish line, right? Which means Ravi After Ravi finishes, Tarun will finish after a total of 120 seconds. So Tarun, Ravi beats, first inference is that Ravi beats Tarun by 120 seconds. You can add the time, the margin measured in terms of time can be added for successive runners, successive finishers, right? Okay. And this is happening over a 2-kilometer race, right? It also tells me that in the same race, Ravi beats Tarun by 400 meters, right? So what does that mean? That Ravi has finished the race, which means Ravi is at 2000 meters and Tarun is some distance behind him. I don't know where he is, right? And the question says Ravi beats Tarun by 400 meters, which means Tarun would be at 1600 meters because he's 400 meters behind him. And that's the distance that Ravi beats him by. So Tarun is 400 meters behind him and Tarun will take another 120 seconds to reach the finish line, which means Tarun runs the last 400 in 120 seconds, which you can directly use as Tarun's speed would now be distance upon time. So 400 divided by 120, I can simplify this and get 410, 43. So 10 by 3 meters per second is the speed at which Tarun runs, right? But that's not the question. The question says find the speed at which Ravi can run the race. At what speed will Ravi run, right? How fast is Ravi in the same race? Now what you know is Tarun runs at a speed of 10 by 3 meters per second, right? So time taken by Tarun will be distance 2000. You know, we'll say distance upon speed, right? So distance is 2000 meters. Ravi runs 2000, sorry. Tarun's time is what we're calculating. Tarun also finishes 2000 meters, but 2000 meters at 10 by 3 meters per second, which means he'll take how much time? He'll take 200 into 3, that's 600 seconds. And if Tarun takes 600 seconds, Ravi will take how much time? You know that Ravi beats Tarun by 120 seconds, which means Ravi will finish 120 seconds before him. So Ravi's time will be 600 minus 120. That's like 480 seconds. Right? And in this time, he runs 2000 meters. So Ravi's speed can directly be calculated at distance 2000 divided by time, which is 480 in meters per second. And you can then simplify this, right? And if I quickly see, oh no, question actually asked me how long. In fact, question only asked me how much time does Ravi take, right? So that's your answer, 480 seconds, right? It didn't ask me for his speed. It asks me how long does Ravi take to finish the race. Ravi will take 120 seconds less than Tarun. So if Tarun takes 600, Ravi will take 480 seconds. Yeah, I hope you guys are able to grasp this, right? But usually in races, whenever you have the distance of margin, when you know that Ravi beats Tarun by 400 meters, right? The other thing that we do usually is you say that these positions for Ravi and Tarun happened after they run for the same time, because they must have started running at the same moment, and the time that Ravi takes to finish the race will be the time taken by Tarun to reach this point, right? So in the same time, the distance run by them are these. So if you say that distance equal to speed into time, then 2000 should be equal to Ravi's speed R into time T, but 1600 will also be equal to Tarun's speed into, let's say, time T. So what you can do is you can divide and you'll get 2000 by 1600 is the ratio of their speeds, right? Ratio of their speeds will be equal to ratio of their distances. This is what you usually do. D1 equal to S1 into T and D2 is equal to S2 into T. And if you divide, then you'll end up getting ratio of distances equal to ratio of speeds, right? And that's a concept we'll use when we deal with questions on races. Yeah. And a very quick illustration of this concept. Let's say question number 15th, the one with no option choices. No, let's not do question 15. Let's do question number 14th. Right? 14 says Avik beats Avik beats Baba. A beats B by 15 meters in a 300-meter race. So 300-meter race, A beats B by 15 meters, which means distance run by A will be 300, but distance run by B will be 15 less, so 285. And these distances are covered in the same time. So immediately I'll say if the time is the same, then ratio of distances will be ratio of speeds. So you could directly say A by B, the ratio of their speeds will be equal to 300 by 285. So 5 into 60, 5 into 5 is 25, 57. So 60 by 57 becomes the ratio of speeds of Avik and Baba. Likewise, question also follows up with B and C. Avik also beats Champak by A beats C by 30 meters in a 400-meter race. Which means again, ratio of their speeds, A by C, will be ratio of their distances. What distances Avik run? He finishes the race, 400. What distances Champak run? He's 30 meters behind. He'll be at 370. So ratio of their speeds will be 40 by 37. And from these two equations, you can eliminate A. So for example, if I calculate A from there, A will be 60 by 57 into B. But from here, A will be equal to 40 by 37 into C. So if I eliminate it, I can simply equate the value of A from both equations, which will give me B by C as 40 by 37 into 57 by 60. So knock the zeros out. 2 3s are 6, 2 2s are 4. What I get is 57 into 2. That's 114 divided by 37 into 3. That's 111. So I get the ratio of their speeds as 114 by 111. Who's faster? Very, very obvious to see that Baba is faster, Champak is slower, right? Because the numerator is larger, denominator is smaller. So clearly B is faster than C. So who wins? B wins. So that part is easy. We should pick a choice where B wins. So it's either going to be A or B. Option A or option B. But that still leaves me with having to find the margin of victory. So let's say I go back and I think, okay, let's say B beats C by X meters in a race. How long is the race? The question tells you the race length. It tells you 190 meters. Right? So if this be true, then again ratio of their speeds, B upon C, will be ratio of their distances. What is the distance that B runs? If B wins the race, then B will run the entire 190, whereas C will run X meters short, 190 minus X. And this should be the ratio of their speeds, 114 by 111, right? So I can equate that and I can get the value of X from here, right? So it turns out that 19 into 10 is 190 and 19 into 6 is 114. So I'll end up getting 190 minus X is equal to 1110 divided by 6. Right? You can actually simplify this. 6 1s are 6, 51. 6 7s are 6 8s are 48. 30 left, 6 5s are 30. So 190 minus X is equal to 185, which means X becomes 190 minus 185. That's 5 meters. So clearly Baba beats Champak by a distance of 5 meters in a 190-meter race. Right? So that's the way that I solve this question. I hope that you guys are able to follow me. Right? Race problems are very important, right? Race problems, even in IIM Rohtak, I guess, is a very important topic. So I hope that you guys are able to get this question. Any doubts, any clarifications, please ask me now. Are you guys able to follow or able to understand this question? So remember, the concept is distance. In a race problem, we'll always say ratio of distances d1 by d2 will be ratio of speeds s1 by s2, right? So race number 1, A beats B in a 300-meter race. So ratio of distances 300 by 285 will be ratio of their speeds. Similarly, second race, A beats C. So second race, I'll again say A runs 400, B runs 30 less 370. And from these two, you can combine and you'll get the ratio of their speeds B and C, right? But the question asked you to apply this on a third race. On the third race also, you'll have to use the same equation, right? Ratio of distances will be 190 by 190 minus x will be equal to ratio of speeds that you got from here. Equate and solve. Right? Well, I hope you guys understood this. I want you guys to try the remaining questions by yourself. Maybe I'll do, given that we have only 20 minutes, I'll quickly try and cover the third question type, which is cubes, right? And if you have any problems, do let me know in the chat over here. I will try and post detailed solutions if you need any, right? So if you have any trouble with any of the questions here, let me know in the chat. I will post solutions to those questions. Okay, let's come to questions on cubes. Let's start with question number 21. Everybody read question 21 and tell me what would the answer be. Right? Again, a shout out to everybody who's watching this for the first time. Please do register. Click on the link below. And if you need the exercise, click on the link below and you will be able to access the exercise. If you haven't subscribed to our channel already, please do so. We're going to post tons of content relevant to IPM, DU-JAT, CLAT, and many, many other exams, right? So please like, share, and subscribe. In fact, those of you who are already subscribed, please do let your friends know and make sure that the Eptitude family grows. So make sure that your friends indeed subscribe to this channel for access to free content. Okay, question number 21. What should be the answer? Okay, Rahan has a quick answer. Kriti agrees. Some of you are still trying, so let me make space on the whiteboard in the meanwhile. I want the rest of you to quickly finish up. It's not that hard a question. It says that a cube of side 8 centimeters is cut. So you take a big cube of side 8 centimeters and this one is cut into how many cubes? Many cubes, right? So smaller cubes of side 4 centimeters, right? Okay. So many questions I can ask. I can quickly think, okay, each cube here, the volume here must be equal to volume there, right? So the first principle is volume of the big cube will be equal to n into volume of the small cube. So if I do that, volume of the cube will be 8 cube will be equal to n into 4 cubes. So if I calculate this, n becomes 8 into 8 into 8 divided by 4 into 4 into 4, and you can see it becomes 2 times 2 times 2. So that becomes 8 cubes. So the big cube will be cut into 8 small cubes. Okay, first part done. What is the question though? Ask me. It says, by what percentage does the total surface area of the cube change, right? Which means if I consider the total surface area of the big cube and then the combined surface area of all these 8 cubes, then what is the percentage increase, right? So what is the initial surface area? Surface area of a cube is 6 into square of its side, 6s square. So that will be 6 into 8 square. This is initial surface area. What about the final surface area once it has been cut? So you'll say this should be 8 into surface area of the small cubes. Surface area of each small cube. Since there are 8 in number, you will multiply it with 8, which means 8 times. What is the surface area of each small cube? 6s square again. That will be 6 into 4 square. Right? So the question asks you though for the percentage change, right? Which means you want A1 and A2. What you want is the percentage change, which would be A2 minus A1 divided by A1 into 100. Correct? Percentage change will be new area minus old area upon the original area into 100. Which, if you simplify this, can also be written as A2 by A1 minus 1 into 100, right? And this is a better way of looking at it, because what I can then do is divide A2 by A1. What is A2 by A1 equal to? Let me calculate that first. So 8 into 6 into 4 square divided by 6 into 8 square. The 6 will get knocked off. 8 will 1 cancel out. I'll end up getting 16 divided by 8. That's 2. So if I take this value and I substitute it there, you'll get 2 minus 1 into 100%. Means the change is 100%. Yeah. So indeed, when you cut a big cube into small cubes, the surface area will increase. And if there are 8 small cubes, it will increase by 100%. You can, I could give you variations on this. I could say, okay, a big cube is cut into 27 small cubes, right? By what percentage? 27 small identical cubes. By what percentage does the surface area, total surface area increase, right? So I could do the same for, different values, right? So if indeed it was big cube into 27 small cubes, then you would say initial surface area would be, and in this case, by the way, 27 small cubes, which means S cube will be equal to 27 into S1 cube will be 27 into S2 cube, which basically means S1 will be equal to 3S2, right? Taking a cube root, right? Okay, which means the side of the big cube will be equal to 3 times the side of the small cube. It's an important result to have. And now if I do the same calculation of surface area, then A1 will be equal to 6 into S1 square, whereas A2 will be equal to 6 into, first of all, A2 will be 27 small cubes. So 27 into 6 S2 square, substituting the value of S1 from S2 from there, 20, or instead of doing this, let's substitute it here. 6 into 3S2 the whole square, which will be like 6 into 9S2 square. And so A2 by A1 will now become 27 into 6S2 square divided by 9 into 6S2 square. S2 square cancelled out. 9 3s are 27 and 6 and 6 goes away. So now it turns out that the surface area actually becomes 3 times. So the percentage change would be 200%. 3 minus 1 into 100 will become 200%, right? So you could, these kind of questions can be recreated with different values, right? I hope everybody is clear with these. Any doubts, any queries? Yeah. I'm going to directly shoot to the one that I wanted to discuss today, which is question number 23. Question number 23, right? Which says what? It says that a cube of side 16, so you have the big cube where S1 is 16 centimeters. right? It has all its sides painted blue. Okay, there's a cube. You paint all of its 6 surfaces in the color blue. This cube is cut into 64 identical small cubes, right? And so of side 4 centimeters. S2 is equal to 4. Even if you didn't have S2, you would be able to calculate S2, because you'd say S1 cube should be equal to 64 into S2 cube. So if S1 is 16, 16 cube, 16 into 16 into 16 divided by 64 will be the value of S2 cube. And you know, you can basically divide 8 2s are 16, 8 8s are 64, 8 2s are 16. So you end up getting 16 into 4. 64 is equal to cube of S2, which means S2 will be equal to 4. Right? So that S2 did not, I mean, even if the question had not given you S2, you could have calculated it. Yeah. But now the question says, if this is cut into 64 smaller cubes, how many of these small cubes will have 2 sides in the color blue? How many of these small cubes will have 2 sides, 2 surfaces painted blue? So this kind of a question needs a little bit of visualization, right? So the first thing you'll notice is each side is cut into 4 pieces, right? So imagine it this way. Let me show you, by drawing a cube, right? So if you imagine a cube looks like this, right? So what I will do is I will cut it into half, and then each half I'll further cut, right? So that way 16 has been divided into 4 4 4 4, right? And the same thing I'll cut this way also, and the same way I'll cut along this way also. Can you see this? So it becomes like a Rubik's cube, right? Rubik's cube usually would have 3 per side, right? But this one is a bigger version, a different version of the Rubik's cube. So if I take one big cube and I cut it into smaller cubes, this is what the figure will look like. Now if all the sides are painted blue, then you'll see that there are 3 kinds, there are in fact 4 kinds of squares, right? All squares at these corners. The corner is a unique spot in a square, because the corner is a square which has this side and this side and this side. All 3 surfaces in the original color, blue, whereas the other surfaces are on the inside, so they won't have any color. Like the bottom won't have any color, the back won't have any color, the left face won't have any color. Can you imagine this? So what ends up happening is that you will get cubes which either have 3 sides, 3 surfaces blue, right? Or you'll have cubes which 2 surfaces blue, or you'll have cubes with 1 surface blue, or none at all. Because there will be some cubes on the inside. No, they'll have 0 surface in the same color. Yeah? You'll have these 4 kinds of cubes, right? The trick to figure out this kind of a question is to work along the various dimensions of the cube, right? So 3 surfaces, will be colored if you work with corners. Each corner will be a place where 3 surfaces, the bottom and these 2 sides will be colored blue. Similarly, this one, the bottom and the left face will be blue, right? So every cube at a corner will have 3 colors. So how many corners do I have? You have 8 corners in a cube. So every corner will give me 1 cube, which means 8 cubes. I'm Anand. I'm not sure if you've joined us just about now. But if you have and you need to look at the exercise, then please click on the link below and you'll be able to access the exercise that we are discussing, right? This is question number 23 from there. Okay, so first thing, all cubes at the corners will have 3 surfaces, right? Let me shade the surface. This is first surface, second surface, and the third surface, right? So these are the 3 surfaces that will be colored blue. So corner, 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 and that back corner, which is not visible. So you'll end up getting 8 corners. Every cube will have 8 corners. So even after cutting, there will be 8 cubes, one for each corner, which will have 3 surfaces in that particular color, right? So 8 cubes will have 3 surfaces painted blue. How about 2 surfaces painted blue? So now if you look at it, if you eliminate these corner squares, all the squares at the edge, but not at the corner. Each of these, square 1 and square 2, cube 1 and cube 2, will have this surface red and this surface blue and that surface blue. But the other surfaces are on the inside, right? So the trick to know 2 surfaces blue is to think these are cubes at the edges, but not at the corner. So how many such cubes do I have that are along every edge? Every edge will contain 2 cubes. And how many edges does a cube have, right? So if you imagine, if you want to count things about a cube, look at the room around you and count the number of edges in the room, right? You can see that the wall behind me will have 4 edges. The wall in front of me will have 4 edges. And these 2 walls will give me 4 edges, 2 at the top and 2 at the bottom. So 4 plus 4, 8, plus 2, 10, plus 2, 12, which means you'll have 12 edges, right? And each edge, given the way that we've cut it, each edge will give me 2 cubes. So there will be, so this is the answer to this question. 24 cubes will have 2 edges, 2 surfaces painted blue, right? That's the answer. How about cubes which have only 1 surface colored? Yeah, I'll repeat this, Manvi. I'll repeat this. Abhi aap follow kar lo the rest of it, right? So first we removed all the cubes at the corners, and then we, you counted all of these, cubes which are along the edges but are not at the corners, right? So for every edge you'll end up getting 2 such cubes, and there are 12 such edges. So in total I will get 12 times 2, 24 cubes, each of which will have 2 surfaces painted red, right? Can you see this? This is red, this is blue, and this is also blue. This is blue and this is also blue. This is blue and this is also blue, etc., etc., right? Lastly, I come to cubes which have only 1 surface in the color, right? So which ones are these cubes? These are the ones marked X. Can you imagine this? The cube that is marked X will have only the front side outside. All other surfaces will be inside the big cube, right? Which means you can't see them, which means it won't be colored. So each surface, so here I'll think surfaces, and each surface has how many cubes? 4 cubes. And how many surfaces does a cube have? Any cube, you imagine the room that you're sitting in, right? It'll have a roof, it'll have a floor, and it'll have 4 walls, right? Which means the cube will have 6 surfaces. So 6 surfaces, and every surface, like the front surface gives me 4 cubes. So 6 into 4 gives me 24. So 24 cubes have 1 surface blue. 24 other cubes have 2 surfaces blue. 8 cubes have 3 surfaces blue. And I have a total of 64 cubes. So 64 minus these values should give me cubes that have no surface blue. So answer will be 64 minus 8 minus 24 minus 24. That's like 64 minus 48 plus 8, 56. And 64 minus 56 is 8. So what actually ends up happening is that these 64 small cubes will get broken down into 8, 24, 24 and 8 cubes, which have 3 surfaces colored, 2 surfaces colored, 1 surface colored, and no surface colored at all, right? That's the way that it will work out, right? Let me repeat, right? Let me repeat this. The idea to get 3 colors, 2 colors, 1 color, and no surface colored is to think for 3, you'll work with corners. For 2 surfaces, you'll work with edges. For 1 surface, you will work with surface, right? And for 0, you'll do total minus the rest, right? So corners. A cube has how many corners? 8 corners. A cube has how many edges? 12 edges. A cube has how many surfaces? 6 surfaces, right? So first thing, you count the number of corners, surfaces and edges. And then you imagine corner pe kitne cubes honge? If you have 8 corners, एक corner pe, in one corner, how many cubes can I count? How many smaller cubes can I count? So at one corner, you will only get 1 cube. Can you see this? So at each corner, I'll get only 1 cube. So 8 corners means 8 cubes. So there will be 8 cubes that have 3 colors. Sorry, 3 surfaces colored. Similarly, for 2 surfaces, right? You'll say work with edges. How many edges do I have? 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, and 12. So you'll have 12 edges. And I can see that along each edge, you have 2 cubes which have 2 surfaces painted, right? This cube has top and the front. This cube has bottom and the front. This cube has left and the front. This cube has right and the front, right? So each of these cubes will have 2 surfaces painted blue. So if every edge has 2 such cubes, so 12 into 2 will give me 24 such cubes. Similarly, for a single surface painted, you will not look at the edges or the corners, you will actually look at the middle, right? Every surface will have some cubes which are in the middle, which do not occur at the corners or the edges. So eliminate all these squares and you will be left with only 4 squares in the middle, which means each surface will give you 4 such squares. And how many such surfaces do I have? 6. So answer will be 6 into 4, 24. And then finally, total minus the rest means 64 minus 8 minus 24 minus 24 gives me the answer as 8. Yeah. Does that make sense? So Arishi, अगर ये एग्जाम में आएगा ना पहली बार, obviously it sounds little hard, right? It obviously sounds like, why the hell would I attempt this kind of a question, right? But once you've learned the trick, corner, edge, surface, once you know this trick and you practice it at home, you can actually attempt this in the exam. And usually, if this does come in the exam, it will probably come as an entire set with maybe 2 or 3 questions. So then it's worth attempting. Yeah, Arushi. Is this clear to everybody? Some of you are asking me, announcement. Some of you are asking us about CLAT, SLAT, or DU-JAT bhi pooch rahe ho. All of these videos are being planned, guys. Very, very soon, next week onwards, we will be doing, we're planning sessions for vocab, we're planning sessions for verbal, we're planning sessions for legal reasoning, we're planning sessions for even GK, right? Especially for DU-JAT, right? So we've done GK for CLAT. We'll also be supplementing with all other sections. So it will all be coming on our channel very, very soon. So please spread the word. Tell your friends about the kind of content that we're going to bring out. Make sure that they like, subscribe to our channel, and follow us. Right? Is that clear, Manvi? I hope it's clear to you, and I hope that you guys are able to try these kind of questions, right? Use the same trick and try the remaining questions in the exercise that I shared, and that should keep you going. All right. Well, that's all I have time for today. I hope that you got a glimpse of some harder variety of questions, right? We'll revert back to our usual modus operandi next week. But until we meet again, make sure that you practice the remaining questions here. If you have any questions, please post it in the comments today, comments below, and I'll be sure to answer you back. Yeah. Thanks a lot. Be safe and see you guys on Thursday, same time, 6 p.m. Do spread the word about our channel. Yeah. Bye-bye. Have a good night.